And hi everyone again. Does it work? Feels like it does, but... Okay, it works. So today we're continuing with our camera stuff. Last time what we did was quite interesting. We tried to move camera around, we tried to avoid all the shaking when we were trying to bypass objects, and it worked to some extent, and we don't fall through the ground anymore. But we still, hey Matt, but we still have an issue that it's shaking. For context, for anyone who didn't see my previous streams, if they're here, I'm making a strategic game using Unity 3D. It's a game where you're a god, you control your hand, you can cast fireballs and whatever, you have villages, some people live in there, and you can conquer other villages by making them believe in you more than in anybody else. That's basically it. And you might remember a game which had the same concept, but whatever. Right now it's in really early stage. As you can see, this is our testing scene, and we have the controls for the hand, but and we can move around, we can turn around like this. I made it slightly slower, but it looks better now, and we can change camera height like this. But with... yeah, that sounds exactly like that game, because it basically is inspired by that masterpiece. And that masterpiece was released a long time ago, and you haven't seen anything similar since. I'm not talking about sequels, they were terrible. So, problem here is that when we're moving onto the ground, we have this shaking stuff. It turns up shaky, it gets back shaky, and it doesn't get back to the full extent, and sometimes you have bugs like this. I have an explanation why this stuff is happening, but who needs the explanation when we need a fix? So I'm going to try and find some better solution. If we look into the code right now, let's open this. We're using magic. And that magic is pure raycasting in direction where we were moving in, trying to hit something, and if we hit something, then we just move the camera up. Of course, it doesn't work really well, because when you're moving onto the slope, the point of contact, if you go straight into your movement direction, is different from the actual point of contact. Means we're lifting too high, and afterwards the moving down action is just not how it should be. Even if I fix this stuff, if it's not moving back down, then it's... because otherwise we're also rewriting the position we want to get back to. So let's use search. What we want to find is... no, first not search. First I wanted to see what physics has in Unity by default. Maybe I don't have to search for random stuff. I just need to find anything that suits me. Closest point returns point on a given collider. This thing does not work with terrain. And I don't know why. It's not mentioned anywhere. Terrain collider. And terrain collider. So closest point, terrain. There is nothing in the manual, there is nothing anywhere at all. In the terrain collider description it has that closest point is here, as if it works, but it just doesn't. And I don't see anything related to this. But there is a simple proof for that. I can add collider in here and earn terrain. Because now I don't know why I like those default values. They don't make any sense at all whatsoever. And here, if I get closest point from B to collider position, what? Position of the collider. What? Point, collider, position of the Huh? What is this? Terrain, transform, position, terrain, transform, rotation. I'm not sure what this stuff is. Maybe this will actually work. Oh yeah, because that was terrain.get collider closest point from B. So yeah, there are those two things. For TMP1 equals this, then our TMP2 equals this, then if TMP1 equals vector 3.0 debug log 1 doesn't work. If TMP2 equals 0 debug log 2 doesn't work either. Hi Dallas. Oh, hi Nicker. You raided me. I didn't think you have 3 watchers. I believe I'm one of those watchers. Hey! Come on, okay, now this stuff should work. And let's go to this, and let's put... What the... Okay, got it. Oh yeah, sorry, I forgot to increase the code size. You know, when I'm doing something for my daily job, I make the size smaller, because it's easier for me to look at that way, and I still forget to make it back bigger when I'm streaming. I will try to not forget that. Okay, let's put this, and let's run this stuff. So, you see, physics.closest point can only be used with box, sphere, or whatever collider, and this relates to both of them, I believe. So physics.closest point, and yeah, so both of them throw the same warning, and I don't know what is the real difference. So I'm not speaking Russian because not all the audience all the time is Russian speaking, and second thing is because I want bigger audience. I believe US audience is more relevant to me because I'm usually this is a sample terrain I've created for this stuff. Yeah, also Unity is an enemy, and to defeat it you have to know it, you have to use its language, and you have to follow its rules. And sometimes you have to find a way to break its rules, which I'm trying to do now, because this, like, convex mesh collider is the same as terrain collider. Same stuff. It doesn't care. It just doesn't want to work. So, let's remove this stuff back. We are sure that it doesn't work. I don't know which value it returns, but it doesn't really matter. And let's find... Right now I'm working on camera. I've shown a little bit in a while, like 5 minutes, 10 minutes ago, but I can show it again. You see right now, the problem is that I have camera controls, but if I control my camera into the ground directly, then it jumps like this. And it jumps like this because of the code I've written, so it's not some magic, and sometimes it still goes through. I wonder why. Because it depends on direction. Okay, whatever. I just hate this shaking stuff. It just doesn't feel right. It should be done in a more beautiful way. And I have to use Google a lot, because I was a Unity developer at some point, but I cannot say I am anymore. Terrain, and when I was, there was and when I was, this stuff was not present in Unity, at least as long as I remember. Find closest point on nav mesh. Nav mesh. So, nav mesh is a navigation mesh that you build on top of your terrain or something, or whichever. So we can build a nav mesh in here and find the closest point on nav mesh. But it sounds even worse than whatever we're doing right now. For a lot of points, get collision points. Physics.overlap sphere. Yeah, I was thinking about this, something like this. Physics.compute penetration, lol. Yeah, you can watch my streams and you can understand a lot about Unity. My zero stream where I was creating this terrain is gone forever, because I just didn't press the right button on Twitch and it was not saved. But everything afterwards, I'm really going to Google, I'm explaining what I'm doing and why I'm doing that, mostly. And also I'm trying to remember how to do stuff. I'm not sure you will understand what game dev is, because game dev is completely random stuff. Game dev is about random people doing random things, and then sometimes there are games that come out and people love them. Though you will understand something. That's what you should see. That's what you usually do with Unity. You see code and you see a small map. And that's it, you don't need much else. Vector, float, radius, closest point, doesn't work, penetration, no idea what that is, get, ignore, ignore. Line cast, overlap, capsule, point, float, radius, sphere. What is this? Returns an array with all colliders touching or inside the sphere. Checks the value not below 0. Now, it's shaken because I can show the line where it's shaken. So I'm calculating this temporary position. This is the huge formula for offset calculation. Then I take square of this and I add it to the previous position and I move. So right here, I'm always moving the camera up, but the amount by which I'm moving the camera up is too big, like way too big. And I'm trying to get better amount for this. And I cannot, because of the way I find this point. I can draw something. So what I'm doing right now, let's assume, yeah, paint. That is really paint. So what I'm doing right now is, we have a slope, we have camera collider. Let's make it look like it's big. And then we're moving camera in this direction right into the slope. Like this. Even better, in this direction. So the moment we touch the slope, right here, slightly better, like this. The moment we touch this slope, we need to find this point. What I'm doing is I'm waiting till camera get past this point a bit, so it touches like this. And then I try to get, come on, and then I try to get the nearest point. It would be this point, somewhere over here. But what I'm really doing is I'm projecting the direction we were moving in, and I'm finding this point. This point. Then I should move the camera upwards. I'm not moving it based on this position, I'm moving it based on this position. Means to make the camera not touch this place, I move it way too high. And it jumps. Because of the human interaction and that you're moving the camera manually with your mouse, it will not be the issue if I get the correct spot at the correct time, because any given moment in time you will make a slight adjustment. That's what I'm trying to do. Like, this is the perfect scenario. Unity is really clever. I can adjust collider on both camera and I have collider on terrain, and it will calculate everything for me. But if I make it, if I make the collider physical, then physics will be applied to this. Means my camera can bounce off stuff, and it will be really hard to track this stuff happening. If I make it non-physical, then it doesn't give me the exact point. No, it's just continue watching. You will see when I fix this stuff. Like, I know I will. Overlap sphere will give me which colliders are nearby, and that doesn't help. Raycast rebuild broad face regions. Wow, they had this. Simulate physics in the scene. Wow. Zoom. So yeah, the up and down is the coordinates. Like up we have y in here, and here we have x, and in the real scene we'll of course have z coordinate, but it doesn't change anything at all. There is no theory so far. Like, I'm not explaining why I have this formula. This formula is purely theoretic, and you can watch my previous stream where I actually made up this formula. Like, with all the explanation how it happens and the Sublime Open and the formula recalculations. Raycast, simulate, slip, so spherecast. What is spherecast? Bool, float, radius. This outrake. This is this thing I want to have. So let's say it's B. What? No. Oh, I have caps lock. B radius is something. Camera collider radius. We're moving. What is direction? What is direction for spherecast? Unity spherecast. What is this? Description. Cast a sphere along an array. Oh. On what was hit. It is useful when raycast doesn't give enough precision because you want to find out an object or specifics. Oh, that is nice. So this thing will tell me if sphere with specified radius moving in specified direction will hit something. So if I'm already, I wonder if it will give me anything if I'm already hitting stuff. For that, I will say that depends. Not much. Like, maximum I had 15 simultaneous viewers, but there were some people raiding me at that moment. And right now I have 9, and that's much more than I usually have. Usually it's about 3 or 4. But let's be honest, it's my 4th stream, so. Okay. Direction being minus previous position, outward hit, sphere, and max distance constant, really small, and layers. Query trigger interaction. I have no idea what that is. What is query trigger? Specifies whether this query should hit triggers. Wow, really? So they've added this sphere cast, so they have physics.raycast, which means I'm selecting a point somewhere in the space, and then I draw a line from there, and I try to find anything that hits it, and if I find it, returns me the exact point which was hit. So they added sphere cast. I'm not casting a line, I'm casting a whole sphere, and I'm moving it, and I'm trying to find if something happens. And also with this sphere cast, now I can trigger the on-trigger events. Means I can project into the future and see if something happens in that future and process it. That is awesome. I cannot use it right now anyway, because there is nothing useful I can do about it, but that's cool. Heat sphere, yeah. So let's save this. Let's do this, and I want the hit point. Debug, lock. Point hit position is matter hit sphere dot point, and TMP value is going to be this. Let's copy this stuff. And it's hit sphere dot point. So I want to measure how big of a difference it will make. Sphere. Come on. And temp here. Like this. So now our sphere collider will not do anything. Our sphere cast. It will just show us if something was hit, and if something was hit, tell us how far we're going to jump up. Basically, it's a square value of how far we're going to jump, but that doesn't really matter. Camera collider radius. I'm not going to multiply it by anything, because it's a nasty trick for this stuff to work. Or maybe by some tiny value. I will explain a bit later why I'm doing this, if it works at all. Raycast hit position. Let's try this. And I got to remove this terrain. I'm not using it anyway. And let's clear this. Okay, now let's move here, and then let's hit something. So we're hitting with raycast, but we're not hitting with spherecast at all, which means we're doing something wrong, most likely. B camera collider radius. Is it radius? Radius, out raycast hit, max distance. Okay, let's not use really small here. Let's say camera collider radius over here. And here, let's give it something. Okay, let's try this. So I'm trying to adjust some random values. That's how debugging works. Try to adjust some random values to see any meaningful results which I can analyze afterwards. Good. Now I have something. Let's see. So first we had several hits with sphere with TMP value of 2, like we're going to adjust slightly up. And initial value was 1.3. So if we get square root of 1.3, it will be something small. Whatever. Just believe me, it's going to be something really small. And then we see 12 over here with zeros. Oh yeah, because I'm using the wrong variable here. Then it's again 3.9, 3.5, and 11. Okay. Now I bet I should make this smaller. Divided by 10. Now I'm doing a bit more random stuff to see if this will give me any more intel. I have a good feeling about my latest change. Okay, let's see the logs. So first was this, then we had the sphere cast, and it was with 3.2 value. So as you can see, the TMP value is significantly different. This 13 gives me a really high jump. This 3 will give me a much smaller jump. The division by 10 makes it more precise, means I catch the difference slightly later, but I catch higher difference. I think we should adjust it by some random amount, and then let's move this logic in here. And here we should say hit.point, and we should remove this. So now I'm fully switching from what is wrong? From double to float. Okay, it's F. Oh yeah, also probably it's because of this stuff. No, they're like 4 times different. It's not that, or maybe. Okay, let's see how it turns out to be. I'm not using any extra precision or anything. Okay, so now I'm fully converting from raycast into the spherecast. I'm projecting where my camera collider will be in some time. Not in some time, it will be in... where's that? It will be if it continues traveling the same direction for this long, for this distance. It's collider divided by 6, radius, it's like some tiny amount. Then if I will hit something, I will jump up. If I don't hit anything, we're good. And this 1.1f seems to be unnecessary for this exact case. Nice. So it was hitting something, but it was not jumping up at all. Why? Let's move really slow here. And here it still doesn't work. Let's see. Oh, we only see raycast hit. We see this sphere hit and then we don't see it anymore. Okay, I see what happened in there. So, by the moment we... Okay, so by the moment we see this, by the moment we enter this collision, we are too far inside and it just breaks everything. And when we have this collision, wait a sec. So, okay, when we're entering the collision, and when we figure that this was cast, we have the value that is too small. Maybe we jump up by this value, but then the next time we check, we still are touching the same collider. And if that happens, we're just not getting this sphere cast. So sphere cast works only on objects that are not touching this sphere. How do we fix this? Let's cast from the previous camera position into the same direction, and here let's use the full radius. I think something like this should help. Again, we will be looking at the stuff that's a bit too far from the camera, but not like it's a big deal. We hit something? Did we? Okay, this is a different story. Yep. No. Okay, so we're hitting something with our sphere, but it still doesn't work properly. And let's say here sphere adjustment is going to be this. Then let's disable the logics that returns objects back to their position, because it might influence whatever we're doing. Head image, where? What? Okay. Sphere adjustment. Okay, let's comment out the reheat. It doesn't matter anymore. I'm looking somewhere in the sky. Nice. Okay, let's go here. And let's try doing this again. So it was adjusted by some extent, by some amount, and I don't even feel this. I mean, this is weird. It should move up. Oh, it moves down. What? I'm moving down for some reason and not up. How can this be? Square of temp plus 8. Most likely I'm making this mistake. But now I'm breaking some formula, which is a bad sign. Usually if you start some heuristics on top of some formulas, you're walking on a slippery slope. Okay, so it's still a bit jumpy, despite our user interaction idea. Okay, now let's move stuff back a bit. And let's do division by 6 over here. Feels like I'm adjusting a bit too high. Okay, the camera in scene for some reason decided to screw up like this. 0.8. 0.8 is 1.6. That's a lot for one single frame, to be honest. Okay, now it's not working anymore at all. What is wrong? By 2. So, why I don't like projecting from the previous point into the current one is because I will have to use more heuristics for that. I actually know what I should be doing. I should be doing a different thing. Different difficulties, B minus previous position. And here, what I should use is previous position, B minus so we're moving from the previous position of the camera into the direction we are really moving in. For the distance we moved, dot magnitude plus constants really small. We have really small constant. It's a really constant float value of 0.0001, and I want to add it just in case. It might make difference for physics, it might not, but I want to try this. And we don't want to multiply anything over here, because if we're touching this, it means we're already touching this point, and most likely TMP value is higher than 0. If it's lower than 0, then we'll touch it again on the next frame. So either is fine for us. Nope. Why such high jumps? What's wrong? So yeah, there is the TMP value that is lower than 0 over there. Like, if I'm moving slow, then it's not a noticeable problem. Like, yeah, I'm trying to make these jumps small and smooth. And I don't want to force and I don't want any smoothing mechanism on the formula, because if we have a really like a really angled slope with a really big angle, then we still want those jumps to happen, because we don't want to ever get inside the slope. And it feels like it's getting fine right now. Like, I'm not sure I want to deal with this any longer. Yeah, it seems to be fine right now. So it's still jumping, but it's jumping on this slope. This slope is huge, like it's a big deal. And I'm putting the point far away, so, and still the jump is not that bad. Possible to make when you slowly. So it is possible to make physics do all this stuff for me, but physics for spherical colliders will add rotation, and for anything else it will add issues. If camera starts rotating, like this starts rotating, even a tiny rotation will break everything apart. You will not be able to play that game anymore. So I'm not going with the real physics way, I'm just going with some hack around way. The next thing I wanted to do, I actually have a tiny plan over here, which you probably haven't seen. This. And we have a bunch of tasks done, we have some stuff done. So the question for anyone who would be looking on YouTube, the question is if it's difficult or not to make game like Transport Fever, and it is difficult in some ways and it is not difficult in some other ways. There is not that much coding, that terrible much of stuff happening there. So the game design is really hard in there, the graphics is great, and it's hard to make that graphics, and it's hard to make all that graphics work. But the game logic itself, just how the trains move and that they load stuff, that they unload stuff, is more or less simple. Again, the more beautiful and the more stable you want to do it, the less simple it is. So, like, I've already poured, I don't know, 14 hours into this project. 12, 14 hours, and it's still in this stage. So how difficult it is depends. So yeah, now we're finding the closest point on terrain, not some random one, which is fine. But I want to add rotations. So instead of just moving it upwards, I want to rotate it around the point. Yeah. So to rotate it around the point, I can use some code that I already have around here. Process camera pitch. Then I will add private void pitch by angle, float angle. And I will separate this logic a bit. Angle, rotate around the hand, get position, so this stuff. There will be a way for us to get into something, but meh. Current rotation X. So where am I using this? Rotate around, transform, blah blah blah, and before that, okay, got it. So I'm rotating around using the method, and then I'm checking the coordinates. Oh, I promised to explain something before I move further. 1 second, I will do this. I'm not using this anymore. Pitch by angle. So the logics that is happening behind the scenes over here. I'm moving the sphere, I'm projecting where it will, I'm moving the camera, then I take the position where it was, the position where it is right now, regardless of how the actual movement was done. I'm only caring about those two positions. I draw the line from the previous position to the new one, and I throw a sphere from that position. I throw it and I see if it bumps onto something, if it moves to the position my camera is in right now, or slightly further, just a little bit. If it hits something, I get the hitting point, it will be the nearest point, and then I move up, and then I move slightly up. This formula over here, that I'm selecting right now, is calculating that exact movement. It's pretty simple formula. You can see how I created it on the previous stream. It's just me taking the point and then knowing coordinates of 2 points, trying to figure out the third coordinate by distances, and that's it. So it's more or less straightforward. Then if my temp variable, which is this distance, it's a square of the distance I should move up, is higher than 0, I will do anything. It can be lower than 0. If the point I'm thinking that is a hit is outside of my sphere, then its distance from the middle of the sphere is bigger than the radius, and then this TMP value will get negative. If it gets negative and I move by negative value, I will move it down first, and second, I cannot take square root of negative value. It will give me a complex number, and we don't care about this stuff here. So I'm only moving if it's positive and if I know how far I should move. That's it. And this block just tells me that I want to move the camera back down and where I started lifting it up. Something like that. So now, I have to transform this movement into an angle around some point. For that, I will have to open Paint again and draw something. So I have 2 points, this and this. I'm sure that those 2 points share the same y coordinate. Like, they don't here, but believe me, they do. And then I have third point somewhere else. That doesn't really matter where. I want to rotate around that point. So you know, game development is an interesting industry. Like, you can earn all the money in there because something you did, like lots of people enjoyed that, and you might lose whichever money you poured into your project, because it's really hard to predict what real people will like, and it's also really hard to market things. So usually for AAA games, the price of marketing stuff is several times higher than the price of developing stuff. Just because otherwise not enough people will see it to buy it to actually give you money for whatever you did. For indie development, right now I'm not spending any money at all, and this Twitch channel and Twitter and YouTube are all ways of advertisement, let's be honest. So I know this point, I know those 2 points now, and I need to calculate this angle between them. This point is somewhere. That doesn't really matter where it is. The angle should be calculated by just 3 sides. So I have all the distances, and I think I can go with that. Yep, let's just search for this. Angle by 3 sides. SSS triangles. Okay. So, yeah, here is the formula. We have cosine product of whichever angle we want. Let's just use it. So one side is this, then let's rename stuff. It's hit point, it's current position, it's new position. It looks like kid is about to wake up. So when my kid wakes up, the stream will be done for today, this day. In the evening I will do one more. Okay. And this is diff y jump. Then let's not do this. Let's calculate the one side. It's I'll still need this new position. Am I actually using this new position anywhere? No, I don't. Okay, I can remove this. Position equals current position, and new position dot y equals this. Then I will need to calculate one side is new position minus the hand position. Position equals the hand dot get position minus hand position dot magnitude. I will need square magnitude, I believe. AB is the angle of C. Yep, I will need the full magnitude, sadly enough. Second side equals alt position. What? Current position minus hand position dot magnitude. So magnitude is the distance between 2 points, basically. I'm creating actually I'm creating a vector that is the difference between those two, and it is the of those 2 points. What? 1 second. Let me think about it. Yeah, that's right. So I'm creating the sides of the triangle, and then the dot magnitude gives me their length. I need this angle where C is my y jump. So cosine equals one side plus second side minus y jump by y jump. Oh yeah, I don't need to calculate this square root anymore. Damn, I need. Oh, come on. Okay, whatever. Divided by, and all of that stuff should be divided by twice the one side, other side. Let's call them A side, B side. Okay. So sphere adjustment angle is going to be math A cos of this. So this A cosinus is always going to be positive because I'm always moving up. Also, it is going to be always less than 90 degrees because I'm not making this high of a jumps, and 90 degrees difference is prohibited anyway. So everything should be fine around this. Let's just make sure that it's bigger than 0 and it's less than 1. That's all we need over here. And then instead of doing this, we will say pitch by angle equals this, angle this. Okay, so now instead of just jumping up, we are pitching. I'm reusing the same code and the same formula I have for pitching in camera movements, so it should be fine. The only way it cannot be fine is if the hand, like this small ball I'm operating with, is somewhere really unpredictably placed. But the only way I can get into this issue is if I'm not moving it manually. 0.4, 0.3. Okay, it doesn't work. Why? I know. Because I need to multiply it by math.p divided by 2. So r cosinus gives me radian, yeah, radians, and I need degrees. Radians to degrees is multiplied by half of p. Can it be? No. Okay, p. Is it? Radians to degrees. Let's just do this. Yeah, multiplied by. Okay, 180 divided by p. Okay, that's what I was thinking about. 180 divided by. I was thinking there should be 180 somewhere. You see, I even can't remember the school formulas easily. I have to think about them, and I have to search for them, and I'm doing that all on stream, so you can learn from this stuff. Though it's a bit easier for me than for some people, because I had this stuff at school. Whoop, whoop, whoop. Yay! we jumped up. But yay, this stuff works. But there is a problem, of course, as usual. We're in game development, of course we have problems. I mean, at least with our sanity. Is there a sane person who will go into game development? Here it goes. So if I move a bit too fast, I'm having the issue about these angles. Yep, that's right. There is no sane person in game development. All of us are slightly not here. But that doesn't make us bad people. Okay. So, problem that we see around here is that if camera is moving too fast, then we're not jumping. We're not doing anything. We just go straight into the train. And as much as I don't want to say it, this is a bug. This is a kind of a bug that I'd like to get fixed, because we're making a prototype over here. But if there are some major bugs that look bad, like, people will notice them. And this bug is really easy to catch. And problem around this stuff is not that we're getting inside the terrain. In many games you can get inside the terrain, like in Skyrim or whatever, even in AAA games. But our hand position depends on where we are compared to the terrain. And if we fall behind the terrain, stuff just doesn't work anymore. So I'm really trying hard to avoid this thing. Let's say div.magnitude plus radius. Wait a second. Camera correlator radius, camera collider radius, camera correlator radius, collider radius, collider radius. I think I know how to fix this without... no, the Fallout, what are the numbers? 69 is a AAA bug, but Skyrim is more of a AAA game. So right now I have, oh my god, 3 collider radius. Holy grail. Let's make it 4. It's 3 meters radius of the camera collider. And it still doesn't help. So, like, if I make it 10, then it will work, but come on. Yeah, of course it will work with huge numbers. Whoop. Yay, this is what happens. You see? I overpitched stuff. So it's more than 0.5, let's say. Yep, I've moved the camera to the top and then slightly more. And it broke the Euler coordinates. And from that point everything will be upside down. And I'm prohibiting this in so many ways. I'm trying to control this, but so you see, I can catch this bug every once in a while, which means real life people will catch it a bit more often, because, like, I've spent 15 minutes with this bug and they will spend hours, hopefully, if they play the game. But that's enough. Let's just say that it's enough. Then now, pitch by angle. And with this movement, we're only changing one coordinate, and this is x-axis rotation, was it? Main camera. So Unity lets me do this. I can watch what values are changing, and I can see that all the values are changing in the rotation, and that doesn't make me feel good. So like this it's only Y, but like this it's everything. And by some decent amounts. Meh. Okay, so I will need to remember how far I moved. Good. Integrate the rotate amount. Let's call it this. Okay. Rotate amount, rotate amount, rotate amount. Let's go here somewhere. Okay, just rotate amount plus equals angle. No. Angle here. And we should move camera back down. Actually, no, we don't need this block of code anymore. Then, let's say we will use the same sphere cast to cast our camera back into place. So if we didn't have to move it up, then we might want to move it down. Let's say we get from current position, we try to move down, we have the radius hit. Oh yeah, sphere hit. Was it called like this? Hit sphere? Sphere, hit sphere. Okay. Let's just rename it to hit. Then it's again. So the distance I will try to move by is more or less indefinite. More or less. Something big enough. I don't like the max value here, I like something smaller. So let's say we can jump per 10 radiuses per frame. Something like that. And here, we will do the same calculation, but we'll do it backwards. We have angle that we want to achieve. We have angle that we can let ourselves to achieve. I noticed your message. Target. What all of this mean? Okay, so I will need this variable. So I'm trying to calculate the rotation I can let myself do. So I'll need this. New position is current position, but y coordinate is let's say it's the position where we hit. Point.y plus camera collider radius. This. Okay, so if we want to move it back down, which is we don't anymore, we don't need this. If rotate amount is bigger than constants dot really small, and the sphere cast worked. So we hit something in there. So if our sphere cast doesn't work, it is still fine for us to move. It means there is nothing down below and we can move as far as we want. What it means? It means I will need to add way more ifs than I want to. How to avoid this? I don't see a way. Okay. So if we want to rotate back, I'm doing this now so I can remove this to do. Find nearest collision. I'm done tests, more or less. So if we hit something, then new position should be somewhere. New position dot y equals hit dot point minus plus camera collider radius dot point dot y. So if we found something down below, we want to move till slightly upper position than we have there. Then we want to check that this new position dot y is smaller than our current position dot y. Equal proceed equals true. If it's not, so proceed equals new position dot y smaller than current position dot y. So then, if proceed, we want to do a bunch of movements. If we didn't hit, then new position dot y equals floor dot min value. It's some really terribly small value, like whichever. We want the cosine products, so that's not a big deal. For hand position equals hand dot get position, and here we do the same stuff. What is this? Why move towards blah blah blah? That is not what I expected to see. A side, B side, cosine product, this stuff. So this time the cosine product should still be positive because 0 is 1, and then going down below makes it stay positive. But here let's say that y jump is the difference between new position dot y minus current position dot y. Moving in that direction. Still, we don't want to move too far. Why don't we? No, we don't care right here. We just care that it's smaller than 1 minus constant really small. Angle equals this. Then we do math dot max dot my of the formula and angle. How did we call this variable? Rotate amount? Angle. So it will be easier to find. And words is this, and we will pitch by minus angle and minus equals angle. Let's try this out. Let's run. No? Compiler errors? Really? Move camera back. That doesn't matter. Previous diff equals diff. Do I use it? I do, and it's process camera pitch. Okay, so here we'll say rotating equals 0f. So when we're moving the camera like this manually with the hand, we don't want to readjust backwards any of those positions. We don't care about that stuff. What we care about is everything else. So now we see that at least we don't trigger this readjustment too soon when it's not necessary. Then let's move into something. Nice. So you see we get whatever. We get... Really? Oh, because with the backwards adjustment I'm hitting this stuff. Okay, I see. So what happens is I'm starting to hit the collider, then the backwards adjustments hit in and moves me even lower because from the current position it is not relevant. We already collided. Vector 3 dot up multiplied by camera collider radius. And then we'll still do the 10 times. And let's play this. Tell us what's up. I see you're not sure about something, but I'm not sure exactly of what. Yep, you see this thing is moving up and down, and now it's getting through the drain, regardless of whatever I'm doing. Why? Because one radius is not enough. If I'm looking inside, it means I need to move 2 radiuses up. Okay. So now I will get my collider definitely out. So I will, yeah, 2.1f. So what I did first was taking my current camera position and looking if there is something below. But it doesn't work if camera is already colliding with something. So I tried looking slightly above the camera position and moving it down and looking down. But it still doesn't work because I was looking from the middle and I need to look from above the camera, like the place that's outside the camera, and if there is nothing in there. Yeah, that drop was an issue with our re-correction that we have here. So like we were being dropped by the logic that puts camera back into the position, and it still does. Now it looks bad. Now we jump higher than anticipated. So, why is this happening? We're jumping by some amount. Then we realign. Meh, that's bad. That got worse. Why is it so jumpy? Let's see the log, whatever is happening over there. Sphere heat position. Adjustment, backwards adjustment, 1.2, 0.2, then again hit. In the end it was shaking like hell. I don't see why, I don't see any good reason for that. So it adjusted up and right away it adjusted down. Which means that I'm somewhere too far. So it means that this adjustment is a bit too big, first. Do I have anything that will tell me why it is too big? Nope. So I'm trying to get from one y coordinate to the other. Yeah, this angle is slightly bigger than what I need. But it shouldn't be that much of an issue. And here, current position, vector 3 dot up, camera collider radius. I don't want this stuff to kick in if I'm already inside the collider. But I don't know how to check it without second ray cast. Without second sphere cast. Okay, let's assume that there is always terrain behind the camera. Let's do this. And let's... Where am I? Let's move this logic out. So, problem was that I'm dropping below the terrain collider, then I don't see anything, and then I readjusting but by the entire angle. Because that's what my logic does. And I don't want that to happen. This. And new position dot y. This. Something like this. Do I have any extra brackets? I don't. Everything seems to be fine. And I'm rotating by the minimum of those two things. Okay, good. It's still shaking. But it's shaking less, and also with this formula I can change this into this. Honestly, I can just use the current camera position, because if I don't hit anything below means that I'm already inside the collider and I shouldn't move anywhere. The raycast hit will not work and I will just fall. And I will just not use this logic. This makes sense. And if you're changing if you're changing something outside the terrain, then just don't expect stuff to work. What? Okay, so with the fast moving stuff, it's a bit weird. Because of how this colliders, how the initial sphere cast works. But otherwise everything seems to be more or less fine. Multiplied by 1.1. So let's look slightly further away. 1.1 float. Thank you. Nah, this is terrible. This is just really bad. I don't want this to ever happen. This is happening because I'm moving into different positions all the time. And that, so both the logics are hitting in. Meh. Going up the slope. Yeah, that's what I'm doing right now. So I'm doing this thing. You're moving into the slope, and okay, it falls through. But how do I show this? Yeah, grab this. It's moving up and then it's moving back down. Something like that. And it is working more or less. But every once in a while it goes right through the slope. And I don't see any good reason for that to happen. Like here, why would it do this? And then I see this shaking problem, which is just absolutely terrifying. But I guess I will have to fix it next time. Okay, so that's it for right now. I will return back this evening, probably. But right now I gotta go. Thank you everyone for watching, and see you later.